Hello, my name is Adrian Ngasamiochu. So my student ID is 4402831. So I want to talk about my LSBU e-rental database system, which is a case study C. So first, let's talk about my database schema. So I designed this entity relationship diagram as seen in my project, which I'm going to submit. So we have a members table here. This for every customer who wants to rent a car must register according to our case study. So we have a members table, and then we have a cars table. This represents a car being rented. So here's the car details, manufacturer, model. We also have the charging details here, the last charge date, etc. So we have the charging logs, which represents these are the charging logs for a specific car. We also here we have the staff table. Yeah, so the staff table is a super type. So I designed the staff table with the staff details, and then the engineer and clerk table all inherit the class table. So the engineer and clerk table only have staff ID as foreign key because they inherit the staff table. So we have a service report. The service report is generated by the engineer for a specific car. So we have engineer and car ID as foreign keys. So it's good to know that in the service report we have is major damage. This is a Boolean field which should determine if the car has a major damage or not. So, and here we have a rental agreement. Finally, we have rental agreements table. So the rental agreements table is generated by a member and a clerk, signed by a member and a clerk, and then is signed to rent a specific car. So he has car ID, member ID, and clerk ID as foreign keys. So now let's talk about task three. Task three. So task three was creating the database and inputting information. So this for my slides, you'll see the screenshots of the code. Sorry, I don't have the code anymore. So I can't run it. Or if I run it, I'll get an error. Sorry. So, but let's talk about task 4, which is my queries. So task 4 was to write a query. So the task 4A was to write a query to find the cars that have not been charged in the last 72 hours. So for task A, B, and C, I wrote views. So the tutor said in class, views are better. It's better to write views than direct queries to prevent SQL injection. So that provides more security to your database, and the user won't have direct access to the information in the database. So the view is just a snapshot of what's in the database. So I created this view negated cars to find the cars which have not been charged in the last 72 hours. So let me run everything. So you can see here, we use the last time the car was charged, which is a max stop time, and then so we to find the hour since the last charge, we subtract it from the present date, basically when the query is run. So I use an inner join. An inner join will exclude any cars which have never been charged. So any new cars which have never been charged will be excluded from this query. And then we go by car ID, manufacturer, model, and then here is to sort out to exclude any cars which have been charged in the last 72 hours, basically. So when we run our code, this is the first query here. We can see these cars have not been charged. The last time they were charged is more than 72 hours. So you can see. So our second query is to 4B was to view members members with less than 3 rentals in the last 3 months. So basically we get the select members details, and then we count the number of rental IDs, because that will represent the number of rentals they have had in the last 3 months. So left join. So we use the left join here to include any member with 0 rentals. So any member who has 0 rental will be included in this query, and then and so basically having count rental ID less than 3. So anyone with less than 3 rental ID will be included. So this is the result. So it shows Harry Osborne, for example, he only has 1 rentals in the last 3 months. So there's it. So what's the time? 5 minutes already. I have to be quick. Sorry. So this task C. So here, so this was to include more data to test the query. So task 4C was for weekly charging report. So this one is easy. We just get the car. So the details, the car details, the start time, so here start time is a date time type field. So we wanted to get the date and the time separately. So we get this as date, you save it as charge date, and as time as start time. So we get the date and the time will start and the stop, and also get the time was we stop charging, and then so the battery level start stop, and then the power used will be the difference, and so yeah, the duration is, yeah, so basically it's easy. And then now we join eCars on a car ID, and the work L dot start time is greater than or equals to so here is to find, yes, is to make sure it's in the last 7 days. So it's the weekly charging report. So make sure that it gives only the last 7 days. And so this is the result of our query. End time, start power level, end power level, yeah, power use, duration, minutes, yeah. So let's go to 4D. So 4D was we have to write the stored procedure, yeah, for cars, for car repair, for a car repair report. It's important to know that a repair is different from maintenance in our database, yeah. So for this, we select the car details, of course, the damage details, the repair cost. Yeah, so we find a sum of, so here this code we find a sum of the repair costs and over partition by car ID. So basically what this does, let's look at the the output of this code. You see it creates the repair cost on one field and the total repair value on the next field. So this is the cost for one repair, and this is the total cost for repair on that same car. So this is what this code does. So then we use an inner join. So an inner join so that it will exclude any cars which have never been repaired. So and then where, yeah, this field where is major damage equals to 1, this will only go to cars which have had major damage. Or I'm running out of time. Let me go to the final one. So this is stored procedure for a monthly statement. So we just get the details of the, yeah, get the details, and then we calculate the days the car was kept, the late days, calculate the rental cost. So the base rental cost, sorry. So this is the cost without the late fee. So we calculate the late fee and the subtotal. I think this would be the addition. We also calculate the VAT. According to our case, so the VAT is 20%, and then the grand total is everything included. So then now this bit of logic is so that we're able to run our code in 3 different ways. You should be able to run it with the member, with the car ID, and without any parameter, so that when both are nulls, the code is still run. So let's look at the output. I have 2 minutes left. So let's look at the output. So here we run when we run on a member, this is on Alice Brown. This shows for Alice Brown. This is for this for Alice Brown here. We run on a specific car. We can see the Tesla model is Alice Brown. Only Alice Brown rented this car 3 times, and then this is for all members in the last 30 days. So in the last month. So that's it. So thank you. So now I'm going to the dashboard quickly. I have 1 minute left. So this is our dashboard we design. So this is our key performance indicators like the total profit, total customers, total rentals. So this is the revenue generated over time here. And this is a member activity. This shows which members are our most loyal customers. So from this we can develop ways to keep these members, like using perks or discounts, and then these members too, we can find ways to incentivize them to spend more in the company. And here we have the total revenue versus total repair cost. So here we can see all the cars in the top left have higher revenue and low repair cost. So these are our best assets, and the cars that will be found here will be our lowest assets. So, and this line is any car above this line is overachieving, while those below are underperforming. So we can, from here we can see that we have many cars which are underperforming. This shows that most of our cars might be old and need more repair, so we need to sell them and maybe reinvest in other cars. And we can see, and and also here we can see the percentage of our cars. You can see most of our cars are Teslas, and most of our cars are Tesla. So this means that if Tesla would depend mostly on this on these cars. Oh, sorry. And then here is one is more important. So here we can see here we have we can see the percentage of our revenue. Which one percentage is from late fees, and which one is from normal rental fees. So from here we can see if the late fees are high, the percentage is high, that means our 24-hour return policy may be too harsh, and we may have to look at that to keep customers. So thank you very much. Sorry, I exceeded my minutes by 30 seconds. Okay, bye-bye.